8.8, Analyzing Decisions. Here's the warm-up. Find each probability. So take a moment to pause the video, then press play to see the answers. Number 1, rolling a 2 and tossing heads when rolling a number cube and tossing a coin. So first off, the probability of rolling a 2 on a standard number cube is 1 out of 6. And, so it's an and probability, which means we will multiply these together. Tossing heads, well, tossing heads is a 1 out of 2 chance. Multiplying those together gets us a probability of 1/12. Number 2, rolling an even number, or, so this is an or probability, rolling a 5. Rolling an even number is 3 out of 6, plus rolling a 5 is 1 out of 6, and there's no overlap there, so we're just adding them together, giving us 4 out of 6, which reduces to 2/3. Okay, number 3, not choosing a multiple of 11 when randomly selecting a number from 0 to 99. Well, I'm going to do 1 minus the probability that I do choose a multiple of 11. Okay, well, multiples of 11 from 0 to 99, well, there's 9 of them. So we do 1 minus 9 out of the 100 numbers, because 0 to 99, that's 100 values, or 100 numbers, which leaves me with 91 over 100. Objectives. Explain that probability can be used to help determine if good decisions are made, and use probabilities to analyze decisions and strategies. We're going to talk about expected value, which we've already talked about this before, but just to refresh your memory, expected value is the weighted average of the numerical outcomes of a probability experiment. So let me type this out. Okay, so again, the weighted average of the numerical outcomes of a probability experiment. So remember, we always calculate probability by doing the number of ways the event occurs divided by the total outcomes. Okay? So kind of thinking about when we're conducting an experiment, the sum of all the probabilities and all their outcomes will always be equal to 1. So just keeping in mind that whenever you add all your probabilities together, you should always get 1, because there's a 100% chance that something will happen. So looking at example 1, and this is a pretty short lesson today, we only have a few examples that we're going to go over. So I have a number cube, and it has the following numbers on each of the sides: 2, 5, 3, 3, 2, and 1. So what is the expected value of rolling the 6-sided number cube as shown in the net below? Well, the value of each side, I'm going to list them out in my table here. I have a 2, 5, a 3, a 3, a 2, and a 1. Well, probability of rolling the first 2 is a 1 out of 6. Rolling the 5 is 1 out of 6. Rolling the 3 is 1 out of 6. Rolling the second 3 is 1 out of 6. Rolling the second 2 is 1 out of 6. And rolling the 1 is 1 out of 6. So when we go to find expected value, or I'm going to shorthand as EV, we're going to do 2 times 1/6 plus 5 times 1/6 plus 3 times 1/6. So we're just basically multiplying each face value by its probability, and we're going to add it all together. Okay, so then plus 2 times 1/6, and then on the very end, plus 1 times 1/6. Okay, multiplying these all out, we end up with 2 over 6 plus 5 over 6 plus 3 over 6 plus 3 over 6 plus 2 over 6 plus 1 over 6. So I just multiplied all the whole numbers by each of the fractions, which really meant I multiplied the whole number by the numerator of the fraction. Adding these all together, you just add your numerators. 2 plus 5 plus 3 plus 3 plus 2 plus 1 gets us 16 out of 6, which reduces to, you could say, 8/3 or 2 2/3. So expected value is about 2.6. repeating.